Hello and welcome back to another episode. Today I want us to talk about the general theory of relativity. Until the early 20th century, physics was mostly explained in terms of Newton's laws. Isaac Newton was a classical physicist who was mostly known for gravity, discovery, and the three motion equations. According to Isaac Newton, gravity is a force generated by mass objects in space causing them to attract each other, where we have the bigger objects attracting the small ones, regardless of the distance between them. This explained well why planets move around the sun. This was upheld until the early 20th century, where a theoretical physicist, Albert Einstein, published a paper on the general theory of relativity. According to Albert Einstein, we live in a three-dimensional space with a width, length, and height. But remember, we move through space in a particular direction. This gives rise to time. Therefore, in his idea, Albert Einstein combined the 3D space and time to form space-time. He saw space-time as a fabric that can be warped by massive objects, forming a curvature we feel as gravity. In his idea, when you place a massive object in the fabric of space, it warps space-time, forming a depression where the smaller objects fall through. E.g., in the solar system, we have the sun at the center of the solar system, which forms a depression, or rather a curvature in the fabric of space-time, and all the planets, satellites, and asteroids fall through. The free fall into the space-time curvature is equal for all masses, which implies that the mass of an object does not affect its free fall or the gravitational pull on the object. Imagine you are in a rocket accelerating upwards in space with an acceleration equal to that of gravity, 9.8 meters per second squared. You will have the same experience as you are standing on the ground. You can tell no difference because of the equivalence principle. Again, Albert Einstein thought what would happen if he was standing on one side of the walls of the rocket and sent light beam. As the rocket is accelerating upwards, the light beam will seem to bend downwards. This violates the equivalence principle, where you should not feel any difference between a rocket accelerating upwards at 9.8 meters per second squared and while standing on the ground. This was only possible if gravity bends light. Remember, light follows the shortest and the most straight path possible. Therefore, how comes that light is being bent by gravity, taking a longer path? This was only possible if space itself is bending. From this, Albert Einstein concluded that gravity is just the curvature of space-time where matter and energy causes the warping. To visualize this in a simple manner, take a trampoline with nothing on the surface and put a bowling ball at the center. You will notice that the trampoline is going to curve, forming a depression at the center, and when you take a marble and put it on the trampoline, it's going to fall towards the center of the depression. The trampoline in this case is the space-time, and in the case of our solar system, the bowling ball represents the sun and the marble represents the planets. But remember, in a trampoline, it's a two-dimensional surface, but the space is three-dimensional, where we have the length, width, and height. That means the curvature is around the sun. Therefore, as we have seen, gravity is not a force, but just a curvature of space-time caused by massive objects, where we have the heavier objects warping the space-time for the smaller objects to fall in. Thank you, and continue supporting the channel by shares and subscription.